going to do is the function g of t is equal to t to the sixth plus 7t to the negative 6. And here we're going to use the power rule. For those that don't remember, the power rule says that if I have a function f of x is equal to x to the nth power, the derivative of that function f prime of x is equal to, if you bring down that power, keep the function the same, and decrease the power by 1. So this is the power rule. This is what we're going to apply here. So if I take the derivative, g prime of t is going to be equal to, bringing this 6 down, I have 2 times 6. Function stays the same. Decrease the power by 1. Plus, again here, 7 times negative 6. Keep the function the same. Decrease the power by 1. Simplifying this, g prime of t is equal to 12t to the 5th plus, this is a negative 42 t to the negative 7th, and this obviously becomes negative, so g prime of t is equal to 12t to the 5th minus 42t to the negative 7th. This is the power rule, an example of the power rule. So just applying this rule into this problem. The second one we're going to do, I have the function h of x is equal to x to the pi plus x to the square root of 2. Here what you have to realize is that pi is just a number, so it still follows that x to the n, where n is an integer, or is a number, I can say number. So here pi is just a number, here square root of 2 is just a number, so if I take the derivative h prime of x, we're going to stick with the x to the n rule, which is the power rule, bring down pi, function stays the same, decrease the power by 1, so it becomes pi minus 1, plus, here we're going to bring down the square root of 2, function stays the same, decrease the power by 1, so it's square root of 2 minus 1. And that's it. So your answer is just h prime of x is equal to pi x to the pi minus 1 plus the square root of 2 x to the square root of 2 minus 1. No simplification needed any further than that. So there's your answer. And again, this is because pi and square root of 2 are just numbers. Third one here, we're going to introduce the product rule with the problem, the cubed root of x squared times the function 2x minus x squared. And recall that the product rule, when I have two functions getting multiplied together, or f times g like that, the derivative is just the derivative of the first function, keep the second function the same, plus keep the first function the same, take the derivative of the second function, and this is going to be equal to h prime. So, to take the derivative of this function, let's say this is equal to h of x. So, h prime of x then is equal to, take the derivative, this is the first function, this is the second function, so I'm going to take the derivative of the first function. Another way from algebra to write the cubed root of x squared is x to the 2/3. So this just becomes power rule. So when I take the derivative of the first function, I'm going to bring down the 2/3. X stays the same, decrease the 2/3 by 1. So 2/3 minus 1, or 3/3, becomes negative 1/3. And I'm going to keep the second function the same. Plus, I'm going to write down here, we're going to keep the first function the same now. Multiply by the derivative of the second function, which is just a power rule as well. The derivative of 2x is 2, minus the derivative of x squared is 2x. And so your answer is just this function right here. And a tip for when you're doing these on the exam this Friday, once you've applied the rule, if they ask you to take the derivative of a product, you don't have to simplify any further than this. The derivative is just the derivative of the first term, keep the second function the same, plus keep the first function the same, the derivative of the second function. So just when you apply that, that's it. You're done. Here's the derivative. You've answered the question. You don't have to simplify, which they will not ask you to do. At least Dr. Schmidt will not ask you to do that. So just apply the derivative rule and just stop there, because once you start trying to simplify, that's where the mistakes start happening, and you don't have to get in that area because you're not required to. Next example, I have f of x is equal to 6x cubed minus x times 10 minus 20x. And this again here is a product rule, although you can either do product rule or you can distribute the both, you can FOIL out and expand this function and then just do power rule. For the sake of just learning this right now, I'm going to do the what did I do here? For the sake of just showing you the product rule, I'm going to do the product rule here. So doing the product rule, the derivative f prime of x is equal to the derivative of the first term and the derivative then the second term. So this is f and this is g. The derivative of f is going to be by power rule 18x squared minus 1, and then keep the second function the same. And then you're going to keep the first function the same, 6x cubed minus x. Take the derivative of the second function, 10 goes to 0. Negative 20x becomes just negative 20. And again, we've applied the power rule here, so we are just done. That's your answer. The next example, w of z is equal to 3z plus 9 over 2 minus z. And this is we're going to talk about in this problem is the quotient rule. When I have the derivative of f over g, which is a function divided by a different function, we are going to get, the rule is going to be down, d up, minus up, d down, all over down squared. You can also say it high d low, low d high. There's a different rules to say. I say up d down d up minus up d down. Down is g, up is f. So down d up means the derivative of the top function minus up. D down is the derivative of the bottom function all over bottom squared, which is the bottom function squared. Don't forget the denominator. Many people forget the denominator on the exam. So always when you're doing quotient rule, don't forget to put the denominator squared to get the quotient rule. So taking the derivative here, w prime of z is equal to down, stays the same, d up, 3z plus 9, the derivative is just 3, minus up, d down, the derivative of 2 minus z is just negative 1, all over down squared. And again, this is just the derivative. You don't have to simplify. You don't have to do anything further than that. Not even distribute the negative 1 if you don't want to. This is just perfectly fine. Actually, this is preferred over doing any simplification on your exam because it just makes it easier for anybody that's grading your exam to look at this and say, down, they took the derivative of the top, minus up, they took the derivative of the bottom, all over down squared. Also, when you're taking the derivative, you should always state that you're taking the derivative of something with capital D or ddx, meaning you're about to take the derivative of that term, just as a side note. Next one here, we're going to get into some trig rules. P of t is equal to sine of t over 3 minus 2 cosine t. So you should know all your trig rules for the exam. They're in your book and they're also in your lecture as well as in the packet. I'm not going to write them all out here, but you should know all the trig rules: sine, cosine, tangent, secant, cosecant, and all the other ones. So just know all your trig rules, cotangent. So those are all of them. So you should know how to give the derivative of all those in terms of x, and then how to apply them in a problem like this. This is just a quotient rule. We're going to go forth with it as a quotient rule. So down, stays the same. D up, now we're going to take the derivative of sine t, which is cosine t, minus up is sine t. D down is going to be the derivative of the bottom, which, if you do the derivative of the bottom, 3 is going to go to 0. The derivative of cosine is negative sine times a negative is just going to be sine. So this is going to be 2 sine t all over down squared. And again, no simplification required. You don't have to combine the signs unless you're doing something with a derivative, like a tangent problem, like using it to do an applied related rate. This is completely fine. We've applied the rule. This is the derivative, unsimplified, and you don't have to simplify it. I can't stress that enough. Don't simplify on the exam because it makes it easier for your professor to grade it when it's unsimplified. And when I say don't simplify, unless asked to simplify, which Professor Schmidt already said that he will not ask you to simplify. Next one. Two over 4z plus e to the negative 9z all to the 10th. This should be f of z. So in this problem, we're going to use the quotient rule, and we're going to also have a chain rule, and we're going to have an exponent rule, an exponential rule, which recall that the derivative of e to the x is e to the x. Also, when we do a chain rule, which is a function of a function, we are going to take the derivative of the outside function, keep the inside the same, multiply by the derivative of the inside function. So this is the chain rule. I'm going to erase just so I have the room to write. So here we're going to start with the quotient rule. F prime of z is equal to down d up, the derivative of 2 is just 0, minus up, derivative of the bottom here. This is a chain rule, with the outer function being to the 10th power and the inner function being this inside function. So the derivative of the outside is 10. We're going to keep the inside function the same, decrease the power by 1. We're going to multiply by the derivative of the inside function here. So the derivative of 4z plus e to the negative 9z is 4, plus e to the negative 9z is a chain rule, because e to the x is e to the x, but we're going to multiply by the derivative of the exponent. So the derivative of e to the x is e to the x times the derivative of the exponent. In this case is just 1. That's why the derivative of e to the x is e to the x. So in this case, we're going to keep e to the negative 9z the same, multiplied by the derivative of the top function, which is negative 9. So we get 4 minus 9e to the negative 9z. That's going to go right here. And here you're all done, except don't forget your denominator, which I almost did. So 4z plus e to the negative 9z to the 10th, all squared. When you are raising an exponent to an exponent, you're going to multiply the numbers. So this would be to the 20th. If you didn't know that, then it's fine to not do that. So I'm just going to leave it like this. And there's your answer. It looks messy, but you're not asked to simplify. You just have to apply the rule. Again, 10, something raised to the 10th, all raised to the squared. You're going to multiply these two numbers. So this would all over be to the 20th power. But if you didn't know that, or you weren't sure that if you add them or multiply them, then just leave it like this. This is fine. So don't take the chance with the simplification. All right, the next one we're going to do is the function g of t is equal to sine to the third of e to the 1 minus t plus 3 sine of 6t. Another way of writing this is sine of that function, e to the 1 minus t, plus 3 sine of 6t, oops, all cubed. So here, if you see what's happening is the outer function is a cubic, the inner function is sine of a function, so here we're going to have 3 chain rules. And so in fact, when we take the derivative of this, g prime of t, we're going to take the derivative of the outside, bringing down the 3, keeping the sine of e to the 1 minus t plus 3 sine of 6t the same, decreasing the power by 1, multiplying by the derivative of the inside. What's the derivative of the inside? It's sine of that function. So we're going to take the derivative of the trig function, which is cosine. Keep the inside function the same, e to the 1 minus t plus 3 sine of 6t. Multiply now by the derivative of the inside of that, which is, here's the exponential function, so we're going to keep that the same, multiply by the derivative of the numerator of this, which is 1 minus t just becomes negative 1, plus the derivative of 3 sine 6t, take the derivative of sine, which is cosine, keep the 6t the same, multiply by the derivative of 6t, which is 6. And there's your answer. Notice how I'm just applying the derivative rule and then I'm stopping. So if you look back at this, the outer function was a exponential, so that's here. Then we took the derivative of the inside function, which is sine of that, so that's this. And then the derivative of that, the derivative of the 3 sine 6t becomes right here, which is another chain rule. So literally we have 3 or 4 chain rules all in one problem, so just be careful when you do this problem and just take it step by step. Alright, the next one here, we have y is equal to the square root of z times sine inverse of z squared. So yes, you have to know the inverse trig rules, and again, I'm not going to write these out for you, but you should know the derivative of sine inverse, cosine inverse, tan inverse. Those are all in your book, and we went over them in SI. So you should have these memorized. Here we're going to start with like a product rule, because we have 2 functions. Here's the f function, here's the g function. So when I start with the product rule, y prime is going to be equal to the derivative of the first. This is just z to the half. So what's the derivative of z to the half? 1 half z decreased by 1 to the negative half. Keep the second function the same, plus keep the first function the same. Derivative of the second term, well, the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. But if this is anything other than x, we have to multiply by the derivative of that function. Here the derivative of x is just 1. So when I do this, the sine inverse of z squared is going to be 1 over the square root of 1 minus z squared squared times the derivative of z squared, which is 2z. And there's your answer. Don't forget the chain. Anything other than just x or just a variable is going to have a chain rule. So watch out for that. The next one, we are going to do implicit differentiation here. X cubed times y to the 5th plus 3x is equal to 8y cubed plus 1. So whenever we're taking the derivative, we are taking the derivative in terms of one variable, which is usually x. It's not y. So if I have 2 variables, x and y, and I'm taking the derivative in terms of x, well, the derivative of just x is 1, but the derivative of just y is going to be 1 with a chain rule y prime. Why? Because y here is a function of x. So this is not just a variable, this is a function, and so in that case, we're going to have to do a chain rule. So watch out for that. That's the concept of implicit differentiation. So here, I'm going to take the product rule. the derivative of the first term, 3x squared. Second term stays the same, plus first term stays the same. Derivative of y to the fifth is 5y to the fourth times y prime. So whenever you have y, you're going to always have y prime when you're doing implicit. Plus the derivative of 3x is just 3 equals the derivative of 8y cubed. Bring down the 3, becomes 8 times 3 is 24, y squared, y prime, plus the derivative of 1, which is 0. We're going to move all the terms with y prime on one side, all the other terms on the other side. What am I going to do? I'm going to subtract this whole term to this side, and I'm going to subtract these two terms to that side. So I'm going to subtract 3, subtract 3x squared, y to the fifth, from both sides. And I'm going to subtract this term to that side as well. So what is it going to look like? X cubed times 5y to the fourth y prime minus 24y squared y prime is going to be equal to negative 3 minus 3x squared y to the fifth. What can I pull out here now? We can pull out a y prime, leaving x cubed 5y to the fourth minus 24y squared is equal to negative 3 minus 3x squared y to the fifth. Divide by this big term here. And y prime is going to be equal to negative 3 minus 3x squared y to the fifth over x cubed 5y to the fourth minus 24y squared. And people always ask me, do I have to replace the y with whatever the function is? Depends on your professor. In this case, this is like more complicated to figure out what y is. So for Professor Schmidt, no. For the other professors, you have to check with your professor. In other circumstances, like when you do logarithmic differentiation, which is actually the next problem, you would have to replace y because that's easy to do. So let's move on to the next one. But in this case, y can just be a function of y here. So and the last one for today is y is equal to x to the fifth over 1 minus 10x times the square root of x squared plus 2. Totally fine to do quotient rule here, a quotient rule and a product rule. It just gets to be a little bit messy. So what we're going to introduce is the concept of log differentiation, which is basically you're taking the natural log of both sides. And why can I do this? Because if I do something to one side, I can do it to the other, and the equation is still balanced. So here, instead of doing this whole mess of product rule and quotient rule, I'm going to take the natural log of both sides. We only do this when when taking log of something helps us. In this case, if I take the log of this function, then the log of a division function splits up into a subtraction and a addition. So I'll show you how that works from algebra. By definition, the natural log of a over b is equal to ln a minus ln b, and the natural log of a times b is equal to the natural log of a plus the natural log of b. So here I'm going to have the natural log of y is equal to the natural log of x to the fifth minus the natural log of 1 minus 10x times the square root of x squared plus 2. And again, the natural log of y is equal to ln x to the fifth minus, this is going to become addition, natural log of 1 minus 10x plus the natural log of the square root of x squared plus 2. And then the negative gets distributed to both terms, equals ln of x to the fifth minus ln 1 minus 10x minus ln of the square root of x squared plus 2. So now I'm going to take the derivative. In this term, y is going to be a function of x like we said before. So when I take this, this is going to give me the derivative of ln y times the chain y prime. Recall that the derivative of ln of x is equal to 1 over x. So the derivative of ln of y is 1 over y prime equals ln x to the fifth is 1 over x to the fifth
times the derivative of x to the 5th, which is 5x to the 4th, minus ln 1 minus 10x is 1 over 1 minus 10x times the derivative of 1 minus 10x, which is times negative 10, minus the derivative of ln of square root of x squared plus 2 is 1 over the square root of x squared plus 2 times the derivative of x squared plus 2 to the 1/2. So what's that become? 1/2. Keep the inside function the same. Decrease power by 1, multiplied by the derivative of x squared plus 2. Here it's just 2x. Of course, you can combine everything. 1 over y prime is equal to 5x to the 4th over x to the 5th becomes 5 over x minus, this is negative 10 times a negative becomes a positive 10 over 1 minus 10x. This I'm just going to leave like it is. I'm going to move this to the bottom because it's negative half. So 2x times a half, this cancels out. So on the numerator I just have an x. On the denominator I have the square root of x squared plus 2 times the square root of x squared plus 2, because this is going to move to the bottom, is just x squared plus 2. Sorry, that's supposed to look like an x. Let me erase that. Why? Because if I move this x squared plus 2 to the negative half to the bottom, the roots cancel out. So an easy simplification there. I'm just kind of cleaning it up a little bit, which again, you don't have to simplify if you don't want to. I'm just, for the sake of not being like a page-long answer, I'm just going to combine this stuff. And then the last step here is you have to solve for y prime. Don't leave it like this because this is not the derivative. You have to solve for y prime by multiplying by y on both sides. And we're multiplying this whole thing by y. So what I end up getting is y times 5 over x plus 10 over 1 minus 10x minus x over x squared plus 2. Here it's easy to replace y because it was already initially solved for y. So we're going to replace y with this original function because we know what y is. So your final answer, y prime, is equal to, what was y? X to the 5th over 1 minus 10x times the square root of x squared plus 2 times 5 over x plus 10 over 1 minus 10x minus x over x squared plus 2. And then this would be your final answer. So these past 11 problems were just a quick review of sections 3.1 through 3.6, which includes the power rule, product, quotient, chain rule, implicit differentiation, log rules, trig rules, and logarithmic differentiation. There are 2 more topics in this chapter, related rates, which we will do next week, and we've already done some problems in SI. Those are posted on eSpace, but I'll do more during the review, and linearization / differentials, which is Monday's section. So those 2 topics will, the related rates we'll touch up again on during the review on Wednesday, and the linearization we're going to go over on Monday in class. So this was a recap of section 3.1 through 3.6. I hope this was helpful. Please make sure that you know how to take derivatives. And again, if you have any questions, feel free to email me. This is Ahmad signing off.